Power to the truth. This is Margo. This is Thursday, December 20th, 2018. And tonight we're going to be looking at earthquakes, especially what's been going on today, and a little follow-up on the CAMS ledger change and manipulation, and a little bit about methane. And I'm going to show you what's going on in the South Pole with a couple of icebergs down there that we've been watching. So we're going to start with earthquakes. As you know, we've had a lot of activity today up here off the coast of Russia, off of Kamchatka. So I've got USGS up, and this is the 1 day or the last 24 hours all magnitudes, and we can see that there have been right at this moment there have been 381 earthquakes worldwide of all magnitudes in the last 24 hours, and this number will go up and down, and as the time ticks by, then like these earthquakes down at the bottom will go away. And so if like yesterday we had 200, then as those drop off, you know, you have to have a lot more in order for it to add up to have 381. So that's almost 400 earthquakes. And I imagine by the time morning rolls around, we will have had at least 400 earthquakes in 24 hours because of this 7.4 that's now been downgraded to 7.3 that happened up here off the coast of Russia. So this is the whole world view. And for people who are not familiar, because I had some people ask, why is it that everything repeats, these maps repeat, but where are the earthquakes over here and over here? Someone asked that, and over on Facebook, and it's the way USGS is laid out, the map flat, and depending on how close in you are, if you zoom out all the way, like here's where you zoom out all the way, there it is. And so it does repeat over and over and over, and it's really tiny, but you only see the earthquakes one time. So I think it's to accommodate different sizes of screens, frankly. And so all of the earthquakes appear when I'm at this view here. So I like it to have North and South America over here on my right, and then here's the tectonic plate coming down in the middle of the Atlantic Ocean, and then here's the Pacific Ocean and the Ring of Fire, and here's Alaska with their big cluster of earthquakes, and here's Russia and Asia and China and so forth. And then this is the South Pacific with Indonesia. This whole area down here is Indonesia, and then you've got Vanuatu and Fiji, and then New Zealand is right down here. And we're going to be talking about New Zealand tonight too, about methane. So see, we just went down. So so let's go up here and do a zoom in. This peninsula coming down is called Kamchatka, and this is part of Russia. And so you've got Alaska up here, you've got Russia over here, this is the Bering Sea, this is the Chukchi Sea, this is the Beaufort Sea, and there's sea ice up here now in the Arctic. And this is the Aleutian Islands, down here, and these are all volcanic, and they go up into, then it goes into the mainland of Alaska. And so wherever you have volcanoes or old volcanoes, you're going to have a greater tendency for other geologic activity as well, including earthquakes. And so we can see that the earthquakes over here off the coast of Russia have pretty much piled up all in one place. And so when you zoom in, and this red line is where these tectonic plates meet. And so the view I have on USGS, to get that, you go up here to the little wheel, and that's the settings, and then you scroll down from the whole top thing, and you can choose on your settings like 1 day magnitude, 2.5, and higher. Now this map I have up is 1 day all magnitudes, and so these are all your different choices you can have. Here's your magnitude, okay, and then you can have them listed newest first, oldest first, largest first, smallest first. And then here are the map layers, and you can choose like the layers, like here's the grayscale, and I was using that for a while, but I like the terrain because you can see the land's green, the ocean is blue, and they also show what it looks like the geography under the water, which is kind of cool too. And here's the street view, and here's satellite view. But I like the terrain view. I like the colors, and they're very pleasing to me. And then you can choose if you want the plate boundaries, the U.S. faults, let's turn those on too, and U.S. hazard. And then you can choose your time zone, whether you want it to show up over here in UTC time or your local time. And I've got mine to show up under my local time so that I don't have to calculate UTC all the time. So that's how I have mine set up, but you can set yours up any way you like. So as we go in closer, we can see all these earthquakes that have happened in this same area here, and up at the top it will tell how many earthquakes are in your view now, and we're looking at 12 out of 380 earthquakes. And so there have been 12 earthquakes, including the 7.3 that happened this morning at 9:01 my time. And there was a tsunami threat when it first happened for coast of Russia and this little island, but that went away, and I don't think anything really happened. I didn't hear anything after that. And then we've had some pretty large aftershocks, and when it's red like this, that's the most recent ones. But we've had aftershocks. We've had 5.6, 5.6, 5.1, 4.9, 4.9, 4.6, 4.8, 4.6, 4.6, and a 4.8 just now. So, and we can see that one of these fell off the map just now, because now it says 11. So see, this number is changing all the time. So, and then they'll all list over here, whichever ones you've got in the view, it's in your list. So you can see depending on how you've got them listed, as to what order they came in. So here's the 7.3, and then the 5.6, 5.6, and then 4.9, 4.9, 4.6, and so forth. And so they've been gradually going down in magnitude, except that we did have this one that was a 5.1, and when you click on it, it shows up blue over here so that you can find it. And then if you want more details, you just click on the link here, and it takes you to a larger page, and you can get more information and so forth. And you click on this map, and it shows you exactly where it was and all that. So it isolates that one earthquake rather than you seeing the whole bunch of them. So that's been going on all day, and also as a result, it set off a lot more activity over in Alaska. Things are ramping up over there, and there's stuff going on, a lot of stuff going on in the US, and I want to show you some tiny clusters that are happening. Okay, these red lines are the US fault lines, so we'll be able to see those, although they're it's kind of hard to tell with the roads too, so we'll just have to discern those. But we can see when we zoom in, I was going to show everyone, you know, I live in the Reno area up here. North of Reno, there's Pyramid Lake, and there were 3 earthquakes that happened up here in Smoke Creek Desert, but they've fallen off the map. But there were 3 up there earlier, and here's a couple in the Mount Rose area, and then there's one down here right on the eastern border of Lake Tahoe at Zephyr Cove, and that was a 1.4. And we can see these fault lines go right through Lake Tahoe. And then Carson City today has had a whole slew of these little tiny quakes, and so I'll move it over so we'll take that Lake Tahoe earthquake off, and we can see this cluster down here. Here's Carson City, and so this cluster has happened to the southeast. So this is at the southern end of Carson City when you're going through, and there's a prison at the southern end, and this is called Prison Hill, where all these earthquakes have been happening, and there have been 29 today. And so when you zoom in, you can see where they're situated, and there is a hill here that when you're driving down there, I've driven down by this area, I know this area, and so here's the 3.6 that happened at 5:24 this morning my time, and then a 3.1 happened at 5:30, so 9 minutes later this one happened, and then all these other little ones have come in today, and down to the very small, like 0.4, 0.1, and northeast of Indian Hills, Nevada. That's all the same area. All of this is the same area here. So, and they were shallow, 10 to 11, here's 11 kilometers deep to about 7 to 6 kilometers deep. So there's that. And the small ones are important because it's showing movement of the magma that's happening. So I want to show you there have been some earthquakes at Yellowstone today too. Right up here in the Yellowstone region, there have been, when I checked it earlier, there have been like 7 or 8. Some of them might have fallen off. Now it's 5. So a couple of them fell off time-wise. But this is the 3.1 that happened this morning about 30 minutes before the 7.3 or 4 happened off the coast of Russia. So there's that, and then it was 30 kilometers west-northwest of West Yellowstone, Montana, and 17 kilometers deep. And then there was one right next to it that was right before that, 829. So this little one came in first. That was a 1.4. And so a lot of times the little ones can be precursors for larger ones. Here's one right in Yellowstone. It was a 0.3 at 2307. So 7. Hang on. So this little one that happened in the middle of Yellowstone was last night, the 19th, at 11:07 my time. And then there's been one up here, a 1.0 at 10:57 this morning. Then another one up here at Virginia City, Montana. It was a quarry blast of 1.4. So that's surely not helping matters any, that they're blasting too. Right next to everything that's going on. So there's another cluster that I want to show you down here. Here's San Diego, here's Los Angeles. This is the San Andreas Fault, this big red line coming through. And right down here, I'm going to turn off those US faults. It just adds a lot of red lines that I don't want to see right now. Okay, so now the red lines we're seeing are roads. Right down here, this whole area has been clustering today. So I'm going to zoom in, and I'm going to count this little one that just came in this whole area. There are 60 earthquakes that we're seeing in this map area. And this is Kaweah Valley, and the Anza Mountain is up here. And I believe this is an Indian reservation. Yes, Kaweah Indian Reservation. So it's right beside that this is happening. And I'm not as proficient at this as Dutch Sense is, and he goes real fast and zooms in and shows you all the fracking and the volcanoes and stuff, and I don't do that. So I just like to look at the little clusters and see. Now here's a 3.5 that happened at 12:18 today, and here's a 2.8, I think the largest one was this 3.5. There's a 2.5. And then the rest are small, and they're all around in this area. So, and then we've got more over here and over here. So 60 all in this little tiny area, I think is quite impressive. So this is a 2.6 over here at Anza, California. So now let's go. I want to go some other places too. And here's a cluster. Oh, we just saw that. That's Carson City cluster. There was a little earthquake that happened near Seattle today. A 1.5. 26 kilometers south of Port Angeles, East Washington. So, you know, you can look at these yourselves. Oh, we just had another aftershock come in up here at Russia, another 4.8. So they're coming in. Let's go up here to Alaska and let me show you where. Okay, now what I have up is the last 30 days of all the earthquakes at 4.5 magnitude or above, and there are 557 on this map. And this looks very similar over here. And remember this big one that happened in Alaska back on November the 30th, the 7.0 in Anchorage, or north of Anchorage? And then they had all those aftershocks, and they had a lot of damage because of where the earthquake happened. It happened on land, and it tore up a lot of stuff. And so now, so that was November 30th, and now we have the 7.3 that happened December 20th. So 21 days later, so 3 weeks. And the one on Anchorage was on the right side of this tectonic plate where the red line is, and the one over here in Alaska, in Russia, is on the left side at the other end of that tectonic plate. So I just find that pretty interesting, if we recall that. So let's hop back over here and let's see what's going on in that Anchorage area. And you can see that there's still it's really still clustering here where that big earthquake happened. And so it's slowed down. There's 95 in this view now. So it's slowed down somewhat, but it's still a whole, it's just like, here's 80. When you zoom in, even here's 80. Here's Anchorage, and the earthquake happened up here. So there's that. And we've also, in the last 24 hours, just going around these plates, we've had a 5.0 at Tres Picos, Mexico, a 4.5 in Nicaragua. When I woke up this morning, this 5.0 in Bolivia was on the map for me. And then 4.4 in Argentina, 4.5 in Chile, and 4.1 in Chile. Now another thing, and then we've got this cluster up here, the Dominican Republic, again on the red line. These are small, so probably no damage. These are 3.5, 2.2, but still they're it shows movement. And then this one right over here on this mid-Atlantic ridge, a 4.9 today at 12:14 p.m. Pacific time, 10 kilometers deep on the central mid-Atlantic ridge, right where these two tectonic plates meet. This is important, and I have to tell you, I had a dream. I've had some visions and dreams recently, and okay, before I go into that, I'm going to show you where we had this earthquake of 5.4 yesterday on the 19th. And it was actually on the 18th for me, because it was 3:38 UTC time, and so it was on the 18th for me. But this earthquake came in, this 5.4, right here in the middle of the Atlantic Ocean, and it was kind of flipping me out because like 3 nights ago I had a dream, and a lot of times I'll dream like I'm looking at cams because I see it so much, and I know what it means when I see black and I'm looking at methane. It's very high readings and so forth. I dreamed I was looking at cams with the methane, and I saw a huge wide thing of methane pluming up out of the ocean. Like it was a long thing like this, and it was wide, and it was coming up out of the Atlantic Ocean right along here. And so that was my dream. And so is it going to happen? I don't know. It could happen. I mean, there's methane in all of the seafloors, and all it's going to take is like one good earthquake to release a whole bunch of this, or one good volcano somewhere to release a bunch of this. I'm going to share an article with you that I think you'll find shocking, talking about New Zealand and the methane deposits under the east coast of New Zealand. So that's just a heads up on that. I also had a vision that where I was looking down on the North Pole, and when I was looking down I saw like a rip just all the way across in the North Pole. I don't know what I was seeing exactly, but it looked like a rip in, I don't know, in the seafloor. I don't know whether it was ripping the ice or ripping the seafloor, but it went all the way across the North Pole. So that's my psychic stuff, or my visionary stuff to share with you all tonight. So see, you get that extra little treat since I'm not a climate scientist. So you get all kinds of extras. So that's why when I see anything over here now in the Atlantic Ocean, I'm thinking about that dream that I had. And then over here, we've had consistent earthquakes over here in the South Pacific. We had some larger ones before today, but they've kind of gone down. That's your 4.8, 4.7. This is Tonga and Fiji. 4.5 Vanuatu. 4.9 Papua New Guinea. 4.9 Papua New Guinea. These are all pretty consistent, about the same. 4.9 Indonesia. 4.6 Philippines. 4.5 Indonesia. 4.4 Indonesia, 4.6 Japan, and 4.5 North Mariana Islands. And then we've had these two earthquakes. I think it's just two. Yeah, one on top of the other. We had this 5.1 in Tajikistan, and this is right above Pakistan. And then, or this is east of Tajikistan. And then 4.6 east of Tajikistan. So that's actually in China. It's just over the border into China with the plateau of Tibet. So here's Pakistan. Tajikistan is here. And then we had this 4.4 in Greece and the 4.4 in Turkey. So those are the main ones. Let's move this back over to get all of our earthquakes lined up the way I like them. So we're now down to 375. We were up to 381 or something like that. So what I'm seeing here is that the earthquakes are getting larger, they're coming faster, and the clusters are becoming more. You're getting more in a cluster, and so you want to watch those as well if you're looking at earthquakes. Next, I have an article I want to share by Westenra. He calls his blog Seymour Rocks. His blog address is robinwestenra.blogspot.com. He just put this up. He's on New Zealand time, so he's a day ahead. So it says December 21st, but he just put this up. And this is kind of in follow-up to our live stream that we did, the last actual show that I did having to do with abrupt climate change. You know, Robin and I did the live stream showing how CAMS had changed the color ledgers and all of that. And by the way, my ticket is still open at CAMS. My support ticket has not been resolved, and they still haven't responded to my original question of which color ledger is correct, and they still have two color ledgers up, even though they changed all the values and everything on one of them, which is supposed to be the current one. But they still have two color ledgers up depending on how you enter the website and whether or not you refresh your page. So this goes right along with what Robin and I had found. He says NASA distorts CO2 data to misrepresent the real situation. Their goal is to make it look normal to the general public and avoid chaos and panic. More faking of data, this time from NASA and concerning CO2, or carbon dioxide. First, for the actual situation. The latest reading from Mount Loa indicated a carbon dioxide level of 410.83 parts per million. And so this is from Hawaii, and week ending December 19th, 2018, from the Mauna Loa Observatory. The carbon dioxide reading was 410.83 parts per million. And here's their graph. Because of fluctuations throughout the year, this is not the highest reading for the year. The highest recorded level of CO2 is 412.6 parts per million in May. So he says highest ever daily average CO2 Mauna Loa Observatory or Mauna Loa Observatory 2018 412.60 on May 14th, 412.45 May 14th on NOAA, 412.37 April 23rd on NOAA. In 2017, 412.63 on April 26th by NOAA, 411.27 on May 15th by NOAA, 2016 409.44 on April 9th by Scripps, 409.39 on April 8th by Scripps. The following was made available to me by a reader and involved in the same trick used by CAMs to trick people into thinking that the situation is not as dire as might be thought. This is how the application NASA Earth Now represented CO2 levels in February 2017. And by the way, just as an aside, you know, I'm into UFOs and UFO research and stuff. And the UFO community, they call NASA never a straight answer. So I think we can probably apply that here too. According to the color code emissions, emissions were approximately 400 parts per million and appropriately represented by red. And this is carbon dioxide, February 2017. And here's their chart. Here's the color code used at the time. And we can see red was 400. And it didn't go above that, obviously. Fast forward to the latest data available from November, and record levels of CO2 emissions for the date, 410 parts per million, are now represented by yellow. For accuracy, this yellow should, by their own standards, be in red, not yellow. And so, October 26th to November 10th, 2018. Now, what was the date on that other one? February. Okay. So now we've October 26th to November 10th. Now it's all yellow and green. That doesn't look too bad, does it? And here's their new color coding. And now there's no red. There's no red on the picture. There's a little bit of red up here at the top, kind of reddish color. But if it's going to be 410, then it should be red, but they've got it in the green and yellow, which is around 405-ish parts per million. And then he says methane data distorted. I've discussed the situation with CAMS, Copernicus, and how they have misrepresented the situation. Here's his video on that. And then he puts in recent articles that he's done as follow-up on, you know, our discussion and the links. Here's the link to Robbins and mine discussion from December 11th and all of that. So his articles are in follow-up after our live stream on December 11th. And so what we found was that, and what we're seeing now is that these agencies are changing the color ledgers and also manipulating the data and we don't really know what the actual data is because, you know, we're just citizen reporters here, citizen observers, and we're not on the inside. No, we're not part of the scientific priesthood to have the real data. And in my mind, it's kind of like, you know, a bookkeeping for an office where you have the real books to show how much money you really have, and then you have the cooked up books for the tax man. And so scientific priesthood has the real data, and it might be so high, and we might be in the middle of the shit hitting the fan right now, which we probably are, but they don't want chaos and confusion with the general public. And so, you know, everything is computerized, and it would be very easy for them to just put an AI algorithm in there and go in and change all the data and have it come down a few notches and then change the ledger and say, oh, it's not so bad now. See, we're not in a crisis anymore. It's not so bad. No need to panic, no need to worry. And we've seen that with NOAA, they either just don't put data up for days on end, or they just put huge white spots right in the middle of the page. So there's that. And Robin also has done a couple of short videos. He just put them up on YouTube. And his YouTube channel is Seymour Rocks 97, and he just put them up showing what I just went over on his blog. If you want to watch those and give him a thumbs up. He's done a couple over there. So you can subscribe to his channel, and he does the little like 30-second, 50-second videos just to get to the nitty-gritty, whereas I go into long explanations. Even though I try and do short videos, it never happens that way. So, the next thing I want to show you is this was my ClimateCast update. This was my last full for the world ClimateCast update from December 2nd, and this is a comment that came in today under that video, and it was from someone that we haven't really heard from before, Francis Formalhaut Moon. I'd like to welcome Francis, and I think this comment is really good, and it turned me on to an article that Robin found for me that I'm going to share that backs up this information. Francis says, one of the 4th largest methane hydrate oceanic deposits is off the east coast of New Zealand. In the form of a sticky white ice cream, this immense deposit is meters thick and covers the east coast seafloor. It remains in suspended animation courtesy of water pressure and temperature. Christchurch lies immediately to the west. In the event of signal water temperature increase, the said hydrate goes gas bubbles, lots and lots of gas bubbles. If a cruise ship, any ship, steams through a consequent aerated concentrate ascending column, it, denied flotation, will sink faster than the Titanic. But I digress. At the gas concentrates of the level of which we speak, the local seawater suffers acidification, turning the construct of the water into largely hydrogen sulfide. This gas, given western wings by a zephyr gently blowing, the said gas concentrations onto the land will do a number on the Canterbury natives. For this reason, all Canterbury dwellings should be outfitted with hydrogen sulfide alarms, 1 per household. Better to be safe than sorry. And I replied, "Thank you, Francis. Is this what you're referring to?" And I put the link, and this is an article that Robin found when I turned him on to that comment. And this is an article from New Zealand Herald. And it's from April 30th of 2015. And it says hundreds of methane gas flares found off the coast of Gisborne, by Jamie Morton, science reporter for New Zealand Herald. A team of scientists have found around 766 individual methane gas flares within an area of seabed off the coast of Gisborne, in what has been described as a major advance for science and a first for New Zealand. Now, in case you want to know where Gisborne is, let's just hop down here. Here's New Zealand, and we can see the red tectonic plate line goes right through the lower island and to the right or the east of the upper island. And Gisborne is right here on the east coast. So we can see that what they're talking about, this area is on this near this tectonic plate as well. The finding comes as the 11-member expedition ends tomorrow morning. This was 2015, with the Niwa deepwater research vessel Tangaroa arriving back in Wellington. The team, led by marine geologist Dr. Joshua Mountjoy, had been investigating the area after German and Kiwi researchers last year revealed 99 seabed gas flares there using state-of-the-art 3D and 2D seismic and echo sounder technology. Following this discovery, Dr. Mountjoy and his team sought to find out whether methane was getting through the water column to the ocean surface and into the atmosphere, and determine what contribution it was making to global greenhouse gas. The first objective of the voyage was to remap gas flares in the area in fine detail using a range of acoustic techniques. Surprisingly, the team discovered that every area of carbonate rock and every fault seen on the seafloor was expelling gas, and in total they calculated there were near to 766 individual gas flares within the area. That was really way beyond expectations, Dr. Mountjoy told the Herald tonight. Flares can occur in these kind of environments, but seeing them in that kind of density is highly unusual, and we certainly found nothing like that in New Zealand before. And so here's their rendition of the 3D image. Shows the seabed environment in which methane gas flares have been observed off the east coast of the North Island. So the gas is stored up in the sediments here, see? And then there are landslides, and then the flares come up. So they observed 766 of these when these guys went out back in 2015. By sampling methane gas within the ocean and collecting photographs and graphic imagery with NIWA's deep-towed imaging system, Dr. Mountjoy and marine ecologist Dr. Ashley Rowden we're also able to build a picture of the fate of the gas flares and acquire a deeper understanding of the ecology at the relatively shallow seep sites. We have recorded video footage showing columns of bubbles streaming out of the seabed, Dr. Mountjoy said. Preliminary indications is that methane is reaching the ocean surface. This is the first time this has been measured in New Zealand. However, to understand how much methane and then what this means for atmospheric contributions will require detailed analysis of the data. So I'm going to let you read the rest of it. Oh, here's one. Some of the gas seeps discovered off Poverty Bay last year had been observed venting from the seabed in flares up to 250 meters high. So, this is happening. So I'll let you read the rest of this article on your own. So considering this is also next to the tectonic plate, and so as everything is moving and shifting, this is going to be releasing methane. So you want to be watching that as well. Also, another thing, I'm going to pull up Climate Reanalyzer real quick. And show you sea surface temperature anomalies for New Zealand. It's quite warm down there. Okay, here it is. This is the Antarctic. Here's Australia. Here's New Zealand. And so the brown, so this is the 2-meter temperature anomaly. And so as you go up from white to brown and red, you're getting higher. And these are in degrees Celsius, higher than they normally are. We can see all the way around New Zealand, it's in the browns, and in this area around the lower island, it's in the reds. And this is in the dark brown here. And also between Australia and New Zealand, it's all brown. So considering this, they found this right here off the east coast of this upper island, right over here. That's pretty disturbing. So what I'm saying is there are methane deposits in all the ocean beds, all the sea floors, and so just you can just expect to see methane coming up out of the ocean. Just expect it, not only in the Arctic where we're looking for it, you know, because we know about the East Siberian ice shelf and the methane hydrates stored under there and the 50 gigaton burst that could happen and all that. But, you know, we've seen it coming up out of the ocean to the east of North America. And look at, you know, that's red and brown as well, sea surface temperature anomaly. And look how red it is around the southern tip of Greenland. So nothing is normal anymore. And to think that things are normal is, you have to open your mind and be looking at the data without any preconceived notions in order to put dots together. And so I'm able to do that because, you know, I wasn't trained as a climate scientist, and I wasn't trained in a certain way to think, oh, well, if this happens, then this has to happen. No, I don't think that. I'm open to all these other possibilities and connect the dots between earthquakes and solar flares and volcanoes and methane and, you know, all of that. So see, you get extra with me, plus my empathic and visionary abilities. So it's, you get the Christmas package. Now, one last thing, and we'll wrap it up because we're going kind of long, which I tend to do. I want to do a follow-up on the Antarctic. We haven't looked down here in a while. And remember down here the Pine Island Glacier and how this iceberg had broken off? Well, we're getting a really good view of this today. And down here, this black area, that's the water. That's the ocean down here. And this is the iceberg from part of it's from last year, part of it's from this year. But remember, we saw it cracking along here. Last year, it cracked off along this line. Last year, and then this water froze back. So this is sea ice, but this is the glacier here. And remember, we saw this crack coming up over here, and I did a whole article on it. And it's really cracked now, and it's now separating and coming away from the glacier is what you can see. And you can see that this was that huge one. Go back and see the video where I talk about the Pine Island Glacier. And did a whole read an article where this guy had found the crack, and I said it could crack off and all that, and it has. Now, and it's summertime down there, and it's the sun's up 24/7, and we can see that it's even started breaking up, and it's this might all break up before the sun goes down next April for them. And one more thing I want to show you, and you can also see how the sea ice is melting here and melting here. And we do expect the sea ice to melt around Antarctica. It typically does. Most of it does melt all around the continent, and that's typical. But remember this iceberg, the A68, that broke off of the Larsen C ice shelf down here? Well, this is a really good view of it today. There are no clouds, and look at this open water to the left of it. So there's not much sea ice left holding it back. I don't know if it's stuck on some ridges or rock, some ridges underneath, but it is turning. And I want to take you back to November. It's still turning to the left. This is kind of cloudy, but you can see the edge of it here. Let me go back. Okay, where we can see it. Okay, so here it is on November the 18th. So it's more of a 12 o'clock position. And now let's go to December 20th. And look, now it's like at an 11 o'clock position. So it's getting ready for its journey. So I don't know when it's going to go out to the open sea. It hasn't moved that far away from the Larsen C. It's just like pivoting. So I don't know if there's like ridges underneath that are keeping it from moving on out. I don't really know. But I just found that quite interesting as well. So I'm going to wrap it up for today. I hope you found this show interesting today. Give it a thumbs up. and subscribe to my channel. I do believe that time is short, and if people haven't watched my latest spiritual videos, if you're so inclined, I recommend you watch them. And I recommend everyone get their spiritual houses in order, because I really don't know how much longer we have. I don't know, this may be my last video. I may have time to do some more, I just don't know. But time is short. I love you guys, and until next time, go in peace. God bless, and goodbye.